Heightened concentrations of greenhouse gases within the Earth's atmosphere are rapidly altering the planet's climate and resulting in negative environmental impacts. Global consensus is that we need to limit warming to 1.5 to 2 degrees Celsius to avoid the worst impacts. And staying within these targets will require rapid and deep decarbonization across all sectors and industries. The power sector presents a key potential pathway for reducing emissions. This is because electricity and heat generation correspond to over 40% of global CO2 emissions, according to the International Energy Agency. The good news is that the energy transition from fossil fuel-based sources to zero-emissions clean energy sources is well underway. This includes renewable energy sources such as wind power, solar power, geothermal power, and bioenergy, as well as nuclear power. Of these, the wind and solar power segments are forecasted to see the strongest growth in power capacity through the medium term and likely beyond, according to the International Energy Agency. Wind and solar power technologies are expected to drive the majority of growth within the clean energy transition. Growth in solar power can come from the continued development of large utility-scale photovoltaic projects, as well as smaller residential, commercial, and industrial solar power systems. For wind power, technology allows for the development of both onshore and offshore projects. While onshore wind power has dominated past growth, the offshore wind power segment is likely to gain significant momentum over the next decade. Additionally, in our view, the widespread adoption of energy storage systems is also key to reaching the high levels of renewable energy that are required to reduce emissions within the power sector. Global energy storage is forecast to explode through 2030, including both battery energy storage systems as well as alternative technologies that allow for longer storage durations, such as compressed air and liquid air energy storage systems. Within the solar power segment, technology advancements to solar cells could lead to more powerful and ultra-high efficiency solar panels, boosting energy production. Digitization throughout the industry and improved racking and tracking technologies could also enhance project performance and reduce costs. In addition, technology advancements could allow for the continued expansion of more nascent solar power applications, such as floating solar projects and agrivoltaics, which is the co-location of solar energy systems and agriculture. Expected technology advancements within the wind power segment include bigger blades, advanced software, and taller turbine towers, which could increase energy production. In addition, technology advancements could allow for the on-site assembly and construction of wind turbines, which could reduce costs. The adoption of renewable energy is accelerating globally as governments and corporations work towards reducing emissions to mitigate climate change and boost energy security. In fact, the International Energy Agency forecasts renewables to account for almost 95% of all power capacity growth globally through 2026. The wind and solar power segments present the greatest opportunities due to their cost competitiveness and the many supportive government policies around the world. Therefore, there could be opportunities throughout the wind and solar value chains, including the manufacturing of wind and solar power equipment, such as wind turbines and solar modules, as well as the development, operation, and maintenance of wind and solar power projects. In addition, there are significant potential growth opportunities in energy storage technologies as well, driven by the global proliferation of renewable energy in combination with increasing grid supply challenges and lower technology prices. Nuclear power is an efficient and zero-carbon emissions source of energy that can provide on-demand baseload power. Therefore, nuclear power can play a vital role in decarbonization efforts for many governments around the world, including the United States. In particular, nuclear power could be a crucial energy source for filling generation gaps associated with the energy transition, including the retirements of baseload coal-fired power plants and the increasing use of intermittent sources such as wind and solar power. The future of nuclear power could lie in the development of small modular reactors, or SMRs, which have a power capacity of up to 300 megawatts, contrasting an average traditional reactor at 1,000 megawatts. Potential benefits of SMRs over traditional nuclear power projects include their potential enhanced safety features, higher flexibility, shorter development timeframes, and smaller upfront costs. Globally, approximately 70 SMR designs have reached various stages of development, with the most advanced projects in Argentina, Canada, China, Russia, South Korea, and the United States.